So we're going to make a pilgrimage to the promised land. And unfortunately, when you're making these type of pilgrimages, you will run into, we'll call them issues instead of problems, right? Issues are there to be solved. So we're making the pilgrim's progress to the promised land. And we're going to start off here with that you've heard of the prophets and their followers and extolling Elixir as a true path to the promised land of concurrent, fault-tolerant, and scalable systems, right? You've heard this. And you've listened to them, you've believed them, and you've decided to make this pilgrimage. You want to get there. That's what you're all about to doing. So we're going to discuss a few things that just might come up along the way. And the first one is, well, the first question is, are you following the right prophets? There are a lot of prophets pushing a lot of different things, and are you following the right prophets? And note, I am not saying they're lying or anything like this. They're not. But the question is, have you chosen the right path? Is the Elixir language and the system the right thing for you? Right? Does it do what you want it to do, the types of systems? Now, to try and answer this, we have to go a little bit back in history a bit. So now we're about 30 years ago. And I was working at Ericsson then in the lab, and we started looking at the problem of programming telecoms, which seems like something completely different here. And this list of properties of that problem was written by our boss then, Bjorn Decker, in the thesis. And if you notice, if you go through that and look, there's absolutely nothing about telecoms in there. There's not a telecoms thing there. The closest might be you want to talk with hardware. But that, again, is nothing specific, like the robots and the parrot, right? But some of these are more interesting than others, and the red ones are the more interesting ones. You want to be able to handle lots of concurrent activities. You've got actions that need to be performed at certain times. You need distribution, because the last one says you need fault tolerance. And if you want to build truly fault-tolerant systems, you need at least 2 computers. Therefore, you need some distribution mechanism around it. You need continuous operation, and so on and so on. And the interesting thing about this is, which we discovered later, was that this, of course, is not just telecoms. We were thinking telecoms, but these problems, these features, properties, are common in other systems. So getting back to, are you following the right prophets? The Erlang OTP and then Elixir, the system is designed for building systems of specific properties. You want lightweight massive concurrency. You want fault tolerance. You want timing constraints. You have timing constraints in your system, and you have to follow these. For example, low latency and things can't wait, et cetera, et cetera. You want continuous operations over a long time. Of course, I've built my system. I don't want to take it down once a day to clean up or do something like this for it. I used to play World of Warcraft, and it would go down about 3 hours every Wednesday morning at 3 o'clock or something like this, and I was doing things for it, which was very annoying when you're sitting there playing, right? So you want continuous operation, and you need distributed systems. So this is what the Elixir, the language and the system is all about. It's for building these type applications with these properties. So, but there are things it's not good at. I'm very embarrassed to mention this, but it's not good at things. It's not good at doing heavy number crunching. We can do it, but you don't want to do it. Trust me. We're not good at doing things where you've got global shared data. We don't like sharing stuff, right? So we're not good at that. And there are other things as well. However, it's not that bad, because one thing we are good at is talking with other systems. So if you need to plug in something else, for example, we're very good at doing that. That's something we've been doing from the very beginning, and we're just good at doing that type of thing. And that typically comes up. I mean, if you're designing large systems or building large systems, you'll find that different parts of the system have different properties. So having one language to rule them all in that sense is probably not the right thing to do anyway. So you want multilingual stuff. We can do this. We've been doing that. So it's not all bad. And you could use, for example, Elixir just as some form of concurrent glue to keep all the other bits and pieces back together again. And it's been done with that. So it's nothing strange. So this is the first stage you have to get over. Am I going the right way? Is this what I'm doing? Or am I doing weather forecasting, in which case I'm probably going very much the wrong way. But you work these things out. So yes, we've decided this is what we want to do. This is the right system for us. This is the right type of applications. The next thing that could happen is you'll get to the joy of the first experiment. Okay. So you've downloaded the system, you've started using the tools, and you've written your first simple thing. It might be a simple Elixir server, it might be a Phoenix web page or something like this, web page written in Phoenix, and it works, right? And you're happy. Because now you're saying, yes, it actually does work. Right? This is nice. The next stage will come, well, now you want to keep on going and work with more things and develop a system and write something serious in it. And you will pretty quickly end up in the village of confusion. This and the next 2 points all fit very much together here, right? And what's the problem here? Well, your system's sort of working, but it's behaving strangely, right? It's not doing quite as you'd expect. This problem is more typical, I'd say, more common if you're coming from a Ruby background. Okay. It just doesn't quite work, right? Now the question is, now we're getting back, did you really listen to the prophets when they were describing their system? Because one thing they very much say very strongly is it may look like Ruby, and by design it does, but it's not. And they will tell you, you go ask her, say, is this Ruby on the beam? And it'll say, no. Right. And it's not. And if you assume it is, you will get into problems. Okay. It's not object-oriented. You can do object-oriented stuff in it, but it doesn't quite work as you expect it to. I can talk more about that later if someone comes up and asks after the talk. It's got a strange handling of data, and it has a strange way of building systems if you're coming from different worlds. So if you're not careful, you'll get into the village of confusion, and you just have to go on and get out of that and go on to make good stuff. Right? So the first place you will arrive at is the hill of functional. Okay. And this is something, again, this and the next one are things you cannot avoid. And the quicker you get up, you climb the hill, the better. The lower the hill is. The longer you push it, the more problems you're going to run into. Right? And the thing here is, we have to understand this, have to climb this hill to understand the language properly. Right? It's not high. Again, the longer you delay, the higher it gets, because then you have more things coming in and become much more confusing. And the basic problem is, Elixir is a functional language. And if you're not used to functional languages, you're going to run into things that are different. For example, we have immutable data. And this is not something you can choose or discuss about or change or anything. All data in the system is immutable. I cannot mutate data at all. The system, basic system, all the way down to the bottom, will not allow me to do that. So I have to get around this problem. I have to work with it. This will change the way I work with data. And the quicker you get into this, the better. Right? The faster it is, get over it quickly. And the same thing, there's this fantastic thing called pattern matching, which truly is fantastic, but it's just a completely different way of working with data. It's very declarative in the style of it. I use this both when building data and when looking at data. So when I'm building data, I don't tell the system how I want to make something. I write it down, and I let the system build it for me, which is very different if you're not used to it. It also ties in with the immutable. And the same thing with patterns. With pattern matching, I have patterns. So I don't write a lot of code saying what this data should look like and test for it and extract values for it. I can just write down a pattern, and the system will do that for me. It will do the testing. It will do the extracting of the values and stuff like this for it. And it's fantastic once you get used to it. You sort of wonder, how could I have survived without it? But the first time you do it, it's really strange, right? Because I'm not doing anything. I'm just writing down a structure and suddenly something works. What's going on type thing. And these are the type of things you will hit. Get over it. Get used to it. Get on with it. And then you can start doing proper stuff. Right? The next one is recursion. There are no basic looping constructs in the language. There are libraries that will do a lot of them, and typically you'll use those libraries. But at the bottom it's recursion, and sometimes you just have to do this yourself. There's just no way around it. And there are a number of other things that come from the functional language environments. It just is a functional language. It's language features. They're strange and different the first time, but after a while you get used to it and it's just not a problem. But the quicker you can make sure they're not a problem, the better. So that's the first one. And the second one is the mountain of concurrency, right? This is actually a bit higher. This is how you use building systems. Okay. So it's about understanding and building systems. It's not high, really, but it feels very different. The path through it feels very different. It's about how you structure systems. And it can be very different from what you're used to. So how do we structure systems? We use processes for it. We explicitly use processes everywhere to do things. We don't share data. Processes are isolated. By design, they're isolated. We don't share data. We don't have any global state. You might think you have global state, but you don't. Right? All communication is just by sending messages. That's it. If you've got two processes, that's how they communicate. But we aren't scared of creating lots of processes. The system allows us to do this, right? So 1,000 processes is nothing. Child's play. 10,000, still not really worth interesting to get it around. 100,000 processes, now we're getting somewhere, right? Now we're starting. Millions of processes, now that is interesting. And there literally are systems in production running millions of processes. Okay? I can argue whether that's a good design choice or not, but the system will do it. And this is just a completely different way of building systems. Again, it takes a bit of getting used to. And eventually you have to do that. And the quicker you can get around this, the easier. And again, the final one, which also can be very strange, is we aren't scared of crashing things, right? Okay, we'll see more about that later. But we aren't scared of building systems where processes keep crashing all the time. That, again, is a very strange way of thinking. But you'll hit these problems, and the faster you can get around, accept them, and get around them, the faster you can go on and doing some interesting stuff, right? So we have these three at the beginning for it. So we're going. The next one we're going to come, so we've built our system, our first experiment. We did our first experiment. We've looked a bit, we now understand a bit about functional languages, we understand about the concurrency, and now we're building our system, but it's crashing occasionally, right? Things are going wrong, which is nothing strange. Things always go wrong in your system, that's nothing strange. But the system is crashing. It's not quite what we expected because we had this dream of making fault-tolerant systems. So what's going on here? So we now have to cross the marsh of fault-tolerant systems. We cannot do anything about this. We have to understand what is going on and how we can work with these things. Right? And there is a big marsh we need to get through. For building fault. And the only way you can get through this marsh is by understanding and learning to build fault-tolerant systems. This is a problem, right? And there are many paths through this. There are many ways of doing this. You just have to find the right path, or the best path of what you want to do. And one very common one, of course, is OTP. It's the OTP path, right? This is a natural choice for many reasons. It was originally designed to support the building of fault-tolerant systems. There are a lot of tools in there for using things, and many things you might have already used, right? For example, you want a server, so you just use the gen server to build a server. There's nothing strange in that. But OTP was designed in such a way that you can plug the things together in the right way to build fault-tolerant systems. That's one of the things it was all about, really, for it. And again, you've probably used a lot of things from this anyway. It's quite natural to do that, even if you're not thinking about the fault-tolerant systems. And, well, another reason it's natural is that the underlying system is built on top of it. When you start running Elixir, it's built on top and using OTP. It uses it extensively. It's used in the underlying system, the Erlang part of it. It's used in the Elixir part of it as well. It uses it everywhere. Whether you see it or you don't, it's all there, right? You're all using it anyway. It has extended it. So one of the things sometimes people don't get about OTP is that it is extensible. And Elixir has used this and extended OTP. OTP has this concept of a behavior, which is something that implements a design pattern. And Elixir has extended OTP by adding new patterns to it. For example, the agent and the task are two new behaviors added to it. And this is nothing strange. The OTP system allows you to do that, extend it. And Elixir has taken this. So yeah, it is used everywhere. And this is generally the best path through the marsh. You can do it yourself for some reason. There might be a reason you can't use OTP and you might want to do it yourself. You can do it. Most people don't. So getting to learn OTP and understanding how it works and how it works with the rest of my system is another one of these things you just have to attack. Right? And when you do, things will become much easier. Okay. So yeah, so now we're going on here. But it does have one property, feature, however you want to see it, that might feel strange, right, if you're coming back. So we're handling using errors. And the classical way of doing error handling is putting tests everywhere to see if everything worked, then try to work out some nice way if something went wrong, right? This is basically not how OTP works. You can use it like that, but the whole idea is not to do that. So what it means is that you have to sit down and think through your system and decide what should the system do when things crash. And note, we say when, because things will crash. I don't know if you thought about it, but the first rule for building a fault-tolerant system is accepting that things will go crash in it and go wrong. You cannot build a fault-tolerant system if you don't accept that, because it will happen. It might be hardware, it might be your software, it might be a library, it might be something, but something will go wrong. What do I do when something goes wrong? And so the idea behind OTP is you sort of sit down and you think of your system, and I've got all these processes running, doing things that are working, and I sort of think, well, what happens if this process crashes? What should I do? Or this type of process crashes, what should I do? Maybe I can just ignore it. Just let the process crash. I don't care, the system will work anyway, and will someone else do the right thing. That is not very common. You have another class of processes which say, yes, this process or this group of processes has to run. The system is not, can't do what it's supposed to do unless they're running. So therefore, I have to make sure that if that process crashes, it's restarted. Okay. I just have to sit down and do these things for it, and I have to make certain when it restarts correctly and stuff like this. And there is support for doing this in OTP. You typically use that. Another class is, yeah, this process crashes, and I will let it crash, because it doesn't make that much difference. But I have to make sure I can clean up afterwards, because the process might have allocated resources, something like this. And if it dies, fine, I will accept that, but I have to make sure I have to clean up afterwards. So getting back to original telecoms world, yes, you might lose a call. As long as it doesn't happen too often, it's okay. But I have to make sure the system continues afterwards and does not crash. Just because I lose one call, the switch should not go down. It's the same thing if you're writing a web server. Yes, you might lose a connection because something goes down, but that should not take down the whole server. Then you've got something seriously wrong in your system. Right? But this takes a lot of planning, thinking through the structure of your system and working out what to do when things go wrong. But it does mean that when you've done this, I can more or less ignore errors in most of the rest of the system. And surprisingly, it works, right? This is where you get your things of 5 or 7 or 9 nines of reliability. It's based on this basic thing is, we're not talking here about the system crashing, but we're talking about things inside, bits inside the system crashing, and the system designed in such a way it can handle those crashes and keep on going, right? The system should never die down. It should never go down. And that's what's called the Erlang let it crash philosophy. And not everyone understands what we're talking about. There was a discussion on Stack Overflow about 3 years ago, I think. They were getting into discussions about the Erlang let it crash philosophy, whether it was good or bad. And one guy there was getting very worked up about this, because he was writing, well, how can you just let things crash? If my system was to crash, it would cost me a few $100,000 every time it happened. So how could you just let it crash? And the problem there was, no one had explained to him, we're not talking about the system crashing. We're talking about little bits crashing and the system surviving. That's the whole goal. But anyway, yeah. So these are things you have to think about, and think about when you're designing a system. And when it works, things can quite happily crash. And you'll actually find systems that people are using and completely happy about it. Then they go start looking in the logs, and they see the things crashing all the time. It's just recovering from the crash and keep on going so no one notices it. Now that's good, But it's also bad because it means that you don't fix the bugs. But yeah, this is something. Well, sometimes they don't even know that something is going. True, I'm not lying here. You have systems where people have not noticed that things are going wrong in the system the whole time because it's recovering and restarting the whole thing. We're just working on it, so they just don't notice it. And yeah, it's fantastic. But yes. Okay, so this is the marsh. You're going to have to cross this marsh. Otherwise, you will not get to building fault-tolerant systems, at least not the Elixir way of doing it, right? So now we go on, and this is a difficult one. Okay, it's the double-edged sword of metaprogramming. So you've been wandering around, and you've been carrying the sword of metaprogramming with you all the time. Okay, from the first time you wrote IEX to start the first system, you've been carrying that sword with you, and you've actually been using it all the time, although you haven't realized it. And often you haven't realized its power. It's a very powerful sword. It's the power to both do good and to do evil, and to do really evil. Right? Okay. So it's there. So what is the sword of metaprogramming? Well, macros. You can write macros in the system. You can buy a book describing how to write macros in the system. I'm an old Lisp programmer, so macros are completely natural to me, and I realize all the things, wonderful things you can do with it, but I can realize all the bad things you can get into it. So if you use it wisely, it is a very powerful tool, and it can be really helpful for describing systems. If you use unwisely, you can lead to code that is totally incomprehensible. You can understand it because I understand this macro and it seems very natural for me to do this, but someone looking at your code, someone else looking at your code has absolutely no idea what's going on. I've written this fantastic macro foo which does 10 different things in it, and they're all coupled together, and I'm very happy about this. And someone else looks at the code and sees the foo and says, what? Trust me, this happens. The thing is, you're already using macros. A lot of the things you're running in Elixir as standard things are macros. And some of them are quite complex, but the trick is making sure they're conceptually simple. So for example, def, for defining a function, is a macro. And it's pretty straightforward what it's doing. It's defining a function. Right? But it's doing some more stuff. It's making sure that the system will now say that this function can be called from other modules and a few other things going on as well too. And it's doing these things built in there. But it's been designed in such a way that all this feels very natural. Same def p is slightly different. Make sure things aren't visible from the outside world, but again, defining functions. Def modules is a macro. There are a lot of macros in the system you're using. And a good macro is very clear what it's all about. This does not mean it has to be simple, but just has to be very clear what's going on in the macro. And if you write a bad macro, it becomes extremely confusing. Again, as I said, I'm a Lisp programmer, and Lisp is all about macros, and it's very easy to write bad macros. Okay, that do things you don't understand. So, yeah, be very aware of this. A problem is macros are a lot of fun. Right? I cannot hide this. It's a lot of fun writing macros. I write this fantastic macro, bang, out pops code I want. Okay. I've skipped over one thing here. Yeah, macros, they run at compile time. A macro, when you use it, you get something that looks like code, and the macro transforms that into code and then passes that on into the compiler. That's basically what you want to do. That's the basic idea behind the macro. And again, you can do a lot of, it's fun doing these things, right? And as I said, there's a book describing how to do it in Elixir. The issue is not to get too excited, right, about this and go too far. This is a known problem, so this is not something new I'm saying here, but it's a known problem, and there are a couple of suggestions about macros, and one is don't do them. Okay, and I think that's a bit hard, to be honest. I think that's a bit hard. Macros do have their place in the system. Another one, which I think is much more correct, never use a macro if I can use a function. A function has the benefit you see very much what's going on there. If I just have a function doing something, I should not use a macro instead to do that. Just replace it. There are a couple of rules, but so yes, if you use macros, if you want to write macros in your system, think about what you're doing. Think about if other people can understand it, or you yourself. I sort of had this rule. I try to write code that if I come back in 6 months' time, I will have understood what I've done. And that's sort of, if I can't understand what I'm doing after 6 months, no one else will understand what I'm doing anyway, right? So that's a bad thing. Think about other people who have to look at your code. And again, that's getting back to it. Macros are both it's extremely powerful tool for doing good and bad, right? Make sure it's for good doing good. Yeah. Yeah, now we're going to hit something which we have avoided so far. The language heaven. We're working at Promised Land, and we have a heavens up there containing containing languages, and Elixir is part of the language heaven. And what we find as we keep on working, that the language heaven is actually multilingual. There is not one language, it's not just Elixir. We hear these tales of things going on here that it's multilingual, and there's squabbling between the various language gods and their followers and things like this, fighting between them and stuff like this. Don't despair. Okay. It's nothing to get worked up about, seriously. And it's extremely easy to get worked up about this, but don't. It's not worth it. It's not worth putting your effort into it. So what we find is that the language heaven is, yes, it's multilingual, but what's actually up there is something we call the Erlang ecosystem. Okay. It's a collection of the languages that run on the beam. Typically, it's not all 14, okay, but you can have them. And they're all parts running on the beam. Erlang's there, of course. Elixir has its natural place up there for it. So this is where you're at. This is actually the language heaven you're using when you're designing your system. And if you choose to use it, you can use whichever one. You can mix them. And the power here is that if these languages follow the rules, which they do, at least these do, they can interact with each other. They can openly interact with each other and support each other. It means, yes, I am running Elixir to build my system. But yes, things will be written in other languages, and I don't have to worry about this. It's not something I should care about. Right? And it means that the whole system becomes much more powerful than any language in it, because they're interacting with each other, because they're talking with each other and doing these things. And this is something you're using. You might never see it, but it's something you're using. So some of the system you're running in Elixir will be written in Erlang, some of it will be written in Elixir. And fine, because they work together. And you never have to notice this. That's very common. You might use libraries that come from the Erlang world. And yes, they interact. There's no big deal. Just do it. So I mentioned the Elixir system itself is built on top of Erlang. It works with it, extends it, and does more things for it. It's there. You don't notice it. You don't have to notice it anyway. The same thing if you're using Phoenix. Phoenix is written in Elixir, and you program it in Elixir, but underneath it happens to use a package, I suppose you could call it, called Cowboy for handling connections. So it's Cowboy that's doing the connection handling for it. Cowboy is written in Erlang, and it just works, right? So this is actually not a problem. And if you get squabbling between the groups, I would say just ignore it. Don't get worked up about it. I have personally, by mistake, started a bit of that squabbling. It's not my... because I was making a joke and people took me seriously. Yeah, just a quick push. It's getting on. Twitter is not a good place to hold an argument. Yes, or discussion. Yes, you've been told this, but unless you actually get into it, you will not believe it. But yes, so I tweeted a joke, what I thought was a joke, because I thought it was just too ridiculous to take seriously. But some people did take it seriously and got into discussion about this thing. Yeah, so avoid these discussions. They're just not worth the effort. Okay, and there is no real cause for doing this. You will use them. You are using the multiple languages, whether you know about it or not. A question that often comes up is, okay, so I'm building my system in Elixir, and I've heard of it. I know Erlang's there. Do I have to learn Erlang? And I think the best answer to that is no. Right? Most of the time, you will not have to learn Erlang. You might, sometimes you don't even have to realize it's there. Occasionally, you will run into it. You're using a library that's written in Erlang, but you're calling it direct from Elixir, which is no problem doing it. And I just have to look in the documentation to find what this library does, and the documentation is written in Erlang. That's usually not a problem, because at that level, the difference between the languages, the mapping between them is pretty straightforward, and there's usually no problem understanding what's going on. And a lot of times you'll find that in the Elixir environment, you will have Elixir libraries that are mappings between you as an Elixir user and the Erlang library below it. Okay. Not always to do that, but typically you'll do that. For example, we were talking about the gen server before. Yes, there is a gen server behavior implemented in Erlang. The Elixir gen server layer is built on top of that and provides a mapping to it from Elixir into that gen server. Nothing strange about this, but it's just there. So get over that. Get over the problem. Get over the thing about there are multiple languages there. And if you see these discussions, you can follow them and have fun with them, but don't get worked up about it. It's not worth the effort, to be honest. Right? And yeah, which is the better language? The one you like. That's about it, right? But this has a lot of benefits, because what this means is that you're in the ecosystem. And anything that's been done that can run in the ecosystem, I can use from any language. So I don't have to use the language it's written in to use these features. I can use any language in here. So for example, yeah, we have a Java system over there, which you might have to access for something. And yes, there are mechanisms for accessing that. So I can talk with these two. The whole system, the systems can interact with each other. Now that happens to be written in Erlang, but that doesn't make a difference. I'm running in the ecosystem. I can use that. So if I want to talk with, if I'm writing my Elixir program and want to talk with the Java system, fine, just do it. It just works, right? This is the benefits of these things. They come from one language. I can use them in the whole system. Now talking with the JVM has a nice little backdoor here, because you've seen something there called Erlang, which is actually an implementation of Erlang running on the JVM. Okay. And it's a very good implementation running it there as well too. So therefore we can talk from the Erlang system, we can talk with JVM through the Erlang system and actually run distributed stuff all over that, and it works, right? I have not tried running Elixir on it, but I can't see there'd be any reason that it shouldn't work. Again, from that point of view, Elixir is not doing anything strange, right? It's giving you a different syntax, a different set of libraries, a different way of working with many things, but it's just running on a basic system for it. It also means, in one sense, you cannot make the wrong language choice. We'll talk more about that later. So yeah. So I just want to, I mean, sometimes you'll see some very heated discussions about this. Ignore them. Right? Get over it. Don't. As I said, look at the joke in them. It's a big joke. Treat it as that. It's not worth treating anymore. So the next thing, you've probably seen these. There are a number of these around the pool of introspection. You've been wandering around and building your system, and you've seen these pools here. So what is this all about, right? So the pool of introspection, it's a pool. You can sit by the pool, and in the reflections of the water, you can look inside your system while it's running. You can introspect into the system and look at things, what's going on inside the system while it's running, and gain understanding of what's going on. Now, depending on your background, this is something quite natural or something quite strange and fantastic, and how the hell do we do this for? But the basic system gives you support for doing that, looking in systems for it. And currently, well, there are a number of tools that do these. Currently, they work in Erlang. But again, as I was saying, the interface between them is very straightforward in that sense. Yes, it's a bit of Erlang syntax, but the mapping from that Erlang syntax into Elixir is straightforward. There's no problem for it. A typical, well, the number of them are standard, more or less standard. There's Observer, which comes with the basic Erlang system. It has a very nice graphical interface for looking into the system and seeing what's going on in the system. I can, for example, trace loads, memory usage. I can look at things. I can look at processes in the system. I can look at my applications, which is an OTP complex for building things put together for it. I can do tracing. I can turn tracing on and off with processes and look what's going on. For example, I'm sort of a bit surprised. Something seems a bit strange. I'm a bit suspicious that one process might be what one process is doing. I can turn on tracing for that processing, so I can see all the messages sent to and from that process. And I can see, is it getting sent what I expected to get, what I expect to be sent to it? Is it sending back replies which I expect? And these things I can do at runtime. DBG is, again, part of the standard release. It's a text-based version. Text-based in this sense means you can run it from the shell. So a quick push here, so one of the things you can do with running these systems, I can have my production system and I can start up a shell to it while it's running and look at the system while it's actually working. Which, again, depending on your background, is very strange or quite natural. And I can plug Observer into it if I've got a graphics interface or run distributed. Or if I can't, maybe I can just start a shell on that and start using tools in the shell, through the shell. And DBG is a common one. It's got a slightly strange interface. The people who designed it liked short function names. So they're all 1, 2, 3, or 4 character long names, which can be quite confusing, but it works. A common tool two common tools from third-party tools are Recon and Redbug. Again, these are tools designed to be run from the shell for just looking at the system itself while the system is running. So, for example, in Recon, I can say, okay, over the next 5 seconds, return the 5 processes that have done the most load. And I'll sit there, and after 5 seconds, it'll tell me, these are the processes that did the most load. I can get information about processes. A lot of things about the system going on while the system is running. Similar with Redbug. The benefit of these is I can do it both on my test system when I'm testing it. I mean, I'm running my test environment. I've built up my test environment, of course. And the test seems to work, but I want to see what's actually going on in the system. I think things might be running a bit slowly. Why is it running this slowly? Or why is the speed changing? Why is it sometimes I run the test, it goes quickly, and sometimes I run it goes slowly? So something is going on in there, so I can look at that. So I can use these tools to look at test environments, but I can also use them to look at my production environment. So my system's is up and running, but sometimes things go strangely, so I can use these tools to go look at the system while it's running and not take it down. That's fantastic. I have to mention Wombat, okay? I come from Erlang Solutions, and this is a product we have. It's also a tool for inspecting, looking at systems. It's more complex than the other tools. I can do more things. It's pluggable, so I can write my own handlers for looking at specific things. And what I hope we can work out, Andra, push this as well, that a very nice deal for systems with small numbers of machines in them. Hope we can get something out for that to get out. It's a very nice tool if you do it otherwise. But yeah, the thing is, these all work in Erlang. But at this level, the interface is very nice. Get used to looking at these. It's quite fantastic looking at the system, what's going on while it's doing there. I can show you some simple examples later on if you're interested. And the Wombat has this feature. I can write my own plugins. If I want to look, for my application, I want to do some specific looking at that, I can write plugins, which I can then, for looking just that, and get information out of the system for it. The other ones are more generic, or they are generic, by the way. So that's the pool of introspection. You will hit it, look at it, get used to it, use it. It's a fantastic way of thinking about the running systems for it. Testing is fine. You must do testing, of course, but it cannot tell you everything. This help you. So after all this, you've got the joy. You've hit the joy of arrival, right? You have made your system here. You've built your system. You built your first real system here, and it works, right? It does what it's supposed to do. It can handle all the load you're expecting it to do. It can survive errors and just keep going, as you hope for it. It just works, right? And yes, this is where we want to get up with. This is where we're going if we can do this. And the path of getting there, it has a few issues along the way. And if you should, yes, you should rejoice. And rejoice about this, of course. But realize the path actually wasn't that difficult as it first seemed. You have these issues, and the idea of pointing these issues is to make sure they don't become problems. And they honestly don't become problems unless you start ignoring them. They won't go away, right? The functional nature of the language will not go away. It's there. Once you get used to it, it's gone. The problem is gone. It's not a problem. Same thing with the concurrency, with building the fault-tolerant systems. You have these issues. Attack them. Then they're gone. They're not there. The second time you make the system, make another system will be much easier because you know all this already. And the basic ideas of, say, using OTP, that's irrespective of what you're doing. They're all the same. Once you learn them, you know it. You know how to sit and think about these systems. You know how to solve the problems that might occur. If this process dies, I need to do this. How's the best way of setting up the system to do that? Fine, I've done it. It's great. And it is not as complex as you would think. Once you accept the fact that they're there, make sure, the whole idea is make sure you have these issues, make sure they don't become problems. And trying to ignore them, that's the guaranteed way of turning them into problems. And yeah, that's basically it. And this is me. So, do we have time for questions? I don't know.
I believe so.
Okay, are there questions we can take? Anyone? Knocked you all dead? Right. Yeah. Yeah, I'll repeat the question probably.
Can we get the mic down to you?
Either that or I'll just repeat the question, might be easier.
Thank you very much, Robert. It's great to hear you talk. I'm desperate to ask you a question about exceptions. One of the things I love about languages is actually more about the philosophy of them rather than the syntax. The syntax is a detail, but one of the things that we get from Erlang is this let it crash. And it's something that I've not seen before and I find really interesting. But I wonder, and then I'm writing Ruby or I'm writing C++, and I wonder whether maybe I just didn't understand exceptions in the first place, because although there's a lot of building blocks around it, you know, usually when we write a function, we write a system call in C, say, we return a result code, and then if we really want to make sure someone looks at the result code, we return an exception, and then we build our language where we're desperate to catch the error as soon as it happens. But really what you're introducing here is something like, well, maybe we should have called it somewhere else. And maybe that's what exceptions are all about all along.
I think it very much, how you handle exceptions or errors, I mean, from my point of view, they're the same thing. Okay. It very much depends on what the system allows you to do. So if you're running, say, something in C++, you might have one process. You cannot let that process crash. Okay. You have to catch the exception and handle the exception in some way. Well, I mean, if you let the process crash, but then the whole system's gone down, and they're not going to like you for that, right? So the reason we can do it the way we do by just letting processes crash is because we have so many processes. We're designing a system. I tend to think of it much more. It's not so much a language with concurrency. It's a system with a language. We're working with the whole system. And our goal was from the very beginning that, yes, errors will occur. So what are we going to do when an error occurs? And a typical case is I'm doing something and I have a bunch of processes working together doing that thing. And if one of the processes, you get an error in one of the processes, maybe the only logical thing is just take them all down. I cannot recover from them. So therefore you let the processes crash, and you make sure that the processes that are working together, they all crash. Because the thing they're doing is just can't go on. In our case it was a call, but it can be anything. It can be a connection into your server or whatever. And then, okay, so now we'll let things crash, and we can make sure all the processes working together crash using links. Now I have to clean up after that. So therefore I have to monitor these processes, or one of the processes in it. And then, so I can, when they crash, I can clean up afterwards. So if they've allocated resources, I can free the resources or whatever it might be, or inform someone else they've crashed. And so then you need to monitor the processes. And then you have to work out, well, if this thing crashes, I actually have to make sure it's still working. So now we have supervisors. So it's based around that. And often you will find, okay, this is very much my interpretation, you're less interested in why it crashes than that it crashes. The why is for looking somewhere else afterwards later, but not so much at runtime. But a quick push, or a quick back there, sometimes it is actually relevant to handle that exception inside the process, and then you do it. It's just basically where is the best place to do it. So you have a try. If I need to catch an exception in a process, I can do that inside a try, and the try will catch that for me, and I can clean up and maybe go on, depending what I want to do. Or maybe I clean up and die anyway, because that's still the best thing to do. But you have to sit and work for it. But there's support for doing either way. I don't know if it quite answers your question, but that's the logic behind it. And that's also the fact that you have a lot of these small lightweight processes. So crashing a process, in one sense, is no big thing. Again, it's very much a rethink. Final comment about that is, when you think about building these systems in Elixir, think about structuring like operating systems. So in an operating system, you have a bunch of processes, and if one of these processes crashes, fine, the other ones will keep going. I can pop up lots of shell windows, and if one of them crashes, the rest of the system will just keep on going. Right? That was our sort of design goal we had for doing that. Things will go wrong, the system must continue. So I had another question on it.
Thanks for mentioning that it is an operating system, because really that's what the Erlang VM, it feels like to me, and that's a good thing. I like it.
Yeah.
My question is, you mentioned that sometimes OTP isn't the right thing. Sometimes you have to go outside of that. Can you give me one example in your career where you've said, okay, OTP is not the right solution for building some system?
Well, maybe this is not so much maybe not building the whole system, but sometimes the way OTP behaviors work is just not what you want. They just do the wrong thing, and you might have to write processes that aren't behaviors that are part of your system, and you have to handle that in some way. You have to do the handling of those outside OTP.
Any chance you have a short story or example of that?
I've managed to avoid it. Yeah. So yeah. No. Well, there are some ways you can get around to that. I mean, as I was mentioning, OTP is extensible. So I have a process that I cannot fit into a behavior. One of the original ones, one of the Elixir behaviors, or some other behavior that's someone's written, which is perfectly does what it's supposed to do. And I cannot fit my process into that behavior. Or if I do, it's so much effort doing it, it becomes ridiculous. So I have to write my own process to do that, just doing something. There is support for plugging that into the OTP system. So I'm writing something which is not a behavior but fits into the OTP system anyway. That's not uncommon to do that. It's actually difficult not to use OTP. I mean, not just because of the practical nature of it. It's there anyway, right? You start up the system, and you're actually running OTP. You can go in, look at the applications, what you're running, their OTP applications. See, everything's part of an application. So but you can do it. But
Do you consider spawning a process directly still within the bounds of OTP, or is it only within the bounds of OTP if you're using behaviors and
again,
existing
it
abstractions?
depends what you're doing. So sometimes, yes, I will spawn processes myself. And sometimes they're not part of the OTP system. I don't care if they crash, right? It doesn't make any difference. But yeah, that's one thing thank you, I forgot to mention that. When you're using OTP, you can write enormous, massively concurrent fault-tolerant systems without ever explicitly creating a process or sending a message or receiving a message, because it just goes through the behavior interface. It's all there. Right? This is nothing wrong. It's just proof that the behavior interface works. Right? The problem that can be is if you don't realize this, that you are creating processes, you're going to get in a lot of trouble. I'm creating a gen server, and I do a start link function to that gen server. That is actually creating a process. And if I don't treat it as a process, I will get get confused. So you can write these systems. Literally, you can have hundreds of thousands of processes and never explicitly start a process anywhere because the behaviors are doing it for you. And I'm communicating with these processes, sending messages backwards and forwards, but I never see it because the behavior is doing it. And that's fine. There's nothing wrong with that if I'm aware of it. There's a question. Fine. If you shout, I can.
That's a long way back.
I was just wondering, on a personal level, how does it feel that after these decades, there's new mindshare coming to something that you started all that time ago, and was it inevitable in your mind that this would happen, or is this just a happy circumstance?
It's not inevitable. I mean, there are a lot of good ideas that get lost along the way, that are never adapted or take a very long time to adapt. Of course, I think it's fun. I think it's great. I think for a certain type of solution, certain type of problem, this is the best solution. So that people using it, I think is great. And whether it's Erlang or Elixir or LFE, of course, which is better than both of them. But from my point of view, it doesn't make any difference. They're all the same basic ideas. The concepts are working. They all work together anyway. I don't see a problem. So yeah, I think it's great. I think it's a realization by the rest of the world that the type of problems we were looking at were much more general than we first thought. And I'll be quite honest. The first time someone wrote a web server in Erlang, I was wondering, what the hell are they doing? Now, why would anyone pick Erlang to write a web server? It's for doing telecom stuff for it. And that, again, we just hadn't sometimes realized how general our problem actually was. And yes, it's taken a long time to get out, but better late than never. And I can say one thing. How many people know what OTP actually stands for? Yeah, you do, yeah. And hopefully you haven't been scared off by that. By the T in the OTP, which stands for telecoms. Because if you look in OTP, there's absolutely nothing about telecoms in it. The closest I think you can get is an ASN.1 compiler. But that's about it, right? So don't get scared about that. So yeah, it was general. It was more general than at least I realized from the very beginning for it. And I'm just happy that people have adopted it. And whether you do it through Erlang or Elixir, I don't care. Right? It's from one point of view, it's the same thing. Pick the interface you like the best and use it. Right? That's where getting back to what I was talking about these language arguments before. They're pointless. Right? Yeah. Syntax is, in one sense, is irrelevant. Use the one that you feel happy with. It works. And it'll work with everything else as well. So I hope that answers your question. Any more before we get kicked off here? Or gently asked to leave?